Assalamualaikum warahmatullahi wabarakatuh. My name is Nofarisha Nabila binti Mazalan. My matric number B0517102000. Today, I will present to my panel about synthesis and characterization of black phosphorus or PANi tin via liquid interfacial method. Table of content for the task are include problem statement, objective, methodology, result and discussion, and for the last one is conclusions. In this project, we highlight several problem statements which are phosphorin as a new emerging material to overcome current 2D material limitation. This is because phosphorin is a monolayer substance that is the most stable allotrope of the phosphorus element at ordinary. Next, lack of energy band gap due to the automatically flat layer. We know that energy band gap at the direct point it is conduction and valence band will cross. However, the stability of phosphorin in PANi synthesis through a liquid over liquid route used as a conducting polymer is different. And for the last one is PANi is also reported to be a great stabilizer to phosphorin from degradation attributed the reaction between phosphorin with aqueous oxygen. There are three objectives for this project. Firstly, to investigate the characterization of thin fins of phosphorin or PANi on the glass substrate. Second is to study the parameter of phosphorin or PANi with electrochemical properties. And for the last one is to analyze the effect of phosphorin or PANi on the carrier's mobility and energy band behavior. Next is methodology. In this chapter, is mainly explain how the data will be collected and how to complete the sample of phosphorin PANi thin film and testing the experiment. To collect the data, we are using the design expert software to achieve a better bandwidth of phosphorin. We know that by using this design expert software, we can design experiments, analyze the data, and the last one is visualize the result. So by using this software, two parameters can be optimized, which are temperature and concentration of PANi thin film. According to this parameter, we can analyze this optimization of PANi phosphorin that has a constant value of thickness, which is 100 nanometer. So this is my flowchart. I think this flowchart is different with previous flowchart because we know that our country have the COVID-19 pandemic COVID-19, right? So we as a student couldn't enter the lab. So for this project, I'm just using design expert software to run my experiment. After that, after I collected all the result, I'm just compare the result with the previous researcher and optimize several parameters to get the best thin film of PANi phosphorin. We know that objective one is to investigate the characterization of PANi thin film. So from the result, we can prove that this PANi thin film of phosphorin have a high carrier mobility, high lithium-able band gap, and strong electrical implant anisotropy transport. Next, according to the objective 2, which to study the parameter of phosphorin, after analyze the data, we can optimize of two parameters, which are temperature and concentration of PANi phosphorin. And the last one is objective 3. We know that objective 3 is to analyze the effect of phosphorin. So the electronic properties of few layer phosphorin only focus on layer dependent behavior of band gap, work function, band alignment, and carrier effective mass. This table shows the value of temperature, concentration ratio of phosphorus, PANi, P composition in PANi, and phosphorin composition. So, by using this value, we can insert it into the design expert software to collect the data. This optimization has two responses. Firstly, phosphorus composition is using square root transform. By using this transform, we can evaluate the value for each source that has been shown in the table 4.2 below, and the formula used where the value of lambda for this transform is 0.5 and the constant value is 100. The F value of 166.59 for the model indicates that it is significant, and F value of this magnitude has a 0.02% chance of occurring due to the noise. Model terms are significant if the P value is less than 0.05. A is crucial model term in this scenario. The model terms are not important if the value bigger than 0.1. Model reduction may improve our model if there are many insignificant model terms. Second response in this optimization is P composition in PANi, also using the same square root transform like response 1. By using this transform, we can evaluate the value for each source that has been chosen in the table below, and the formula used where the value of lambda for this transform is 1.0 and the constant value is 100. So, the P value is less than 0.05, indicate model terms are significant. In this case, A is significant model term. Value greater than 0.1 indicate the model terms are not significant. If there are many insignificant model terms, model reduction may improve our model. After we analyze the data, we get a several type of graph between response 1 and response 2, but we can make it hypothesis for response 1 where the higher the temperature, the higher the phosphorus composition. However, for the response 2, we also can make it a hypothesis where the higher the temperature, the higher the P composition in PANi. Scanning electron microscope, or we call it SEM, is used to focus beam of high energy electron to generate a variety of signal at the surface solid specimen. We know that signal that derive from electron sample interaction reveal information about the sample, including external morphology, chemical composition, and crystalline structure and orientation of material making up the sample. However, in the most application, data are collected over a selected area of the surface in the sample. And SEM also capable of performing analysis of selected point location on the sample that we approach, especially useful in qualitative or semi-qualitative. And it can be determine a chemical composition using EDS, crystalline structure, and orientation and crystal orientation using EBSD. SEM can be divided into 4 parts, which are principle, instrumentation, application, strength, and limitation. For principle, secondary electron and backscatter electron are commonly used for imaging sample. However, extra generation also produced by inelastic collision of the incident electron with electron in the skew orbital of atom in the sample. For instrumentation, there are several types, which is electron source, electron lens, sample stage, detector of all signal of interest, display or data output device, and for the last one, infrastructure requirement. SEM is used to generate high-resolution image of shapes of objects and to show spectral variation in chemical composition. And the strength, most of SEM are comparatively easy to operate with user-friendly intuitive interface. Limitation, horizontal dimension is useful on the order of 10 cm. Vertical dimension are generally much more limited and rarely exceeds 40 nanometer. Both graphs shows the SEM result that have been analyzed from previous research. The differences between this graph is energy band gap. The top value of the graph for energy band gap is 3.83 eV. For the bottom graph is 3.84 eV. However, average weight and average thickness for both are the same, which are 5 micrometer and 0.3 milligram. Furthermore, this both graphs also show the SEM result that have been analyzed from previous research. The difference between this graph is energy band gap. For the top is 3.86 eV, for the bottom is 3.84 eV. However, this graph shows the same average weight and average thickness, which are 5 micrometer and 0.35 milligram. Next, these both graphs show the SEM result that have been also from previous research. The difference between this graph is energy band gap, similar to the another graph, but top graph have a value 3.85 eV. For the bottom graph, 3.83 eV. However, average weight for both is 5 micrometer, but the average thickness for both are not the same, because the top graph 0.3 milligram and the bottom graph is 0.35 milligram. In conclusion, the data collected are analyzed, and significant conclusion for this objective has been done. To produce the best thin film, we need to optimize the both parameters, which are temperature and concentration of PANi phosphorus. Using design expert software since pandemic COVID-19 have been spread in our country. The constant thickness has been used for this parameter is 100 nanometer. However, after making an optimization between the two parameters, I found that the temperature value of 200 degrees Celsius obtained the best thin film as it produced the high lambda. In contrast to previous research, where they produced the best thin film by looking at the energy band gap. In fact, they used an average thickness 5 micrometer and the average weight range in 0.3 until 0.35 milligram. That's all. Thank you for lending me your ears.